Hey guys, Mr. Backerberg here. In this video, we're going to look at the derivative of the natural log of x. So as we're looking at finding the derivative of a natural log of x, so if we have the equation y equals the natural log of x, we're actually going to use an inverse property to help us out with doing this derivative. And the inverse of a natural log is actually an e exponential. So rewriting this using an inverse, this would say e to the y equals x. And then we're going to differentiate this thing implicitly using what we know about e exponentials. So if we do the derivative of the left-hand side, the derivative of e raised to something is just that exact same thing, e to the y in this case. But then, because we're doing this implicitly, and we just differentiated something with a y in it, we would have to attach the derivative of whatever that y thing is. Now on the right-hand side, if we differentiate that x, that's just 1. We want to solve to get dy dx alone, so I'm going to divide that e to the y over to the other side. So this is going to say dy dx is equal to 1 over e to the y, but then I can do some substitution, because I know that e to the y is just my x. So this just becomes 1 over x. So the derivative of the natural log of x is just 1 over x. Now we've mentioned it before with some of our other functions, but this x might itself be a differentiable function. So if we have an equation that's like y equals the natural log of u, where u is some differentiable function, then based on the chain rule, as we're doing this derivative, this would be 1 over u, but then we would have to multiply by whatever the derivative of that u function is on the inside. So in this example, we're going to look at finding the derivative of y equals the natural log of x squared plus 4. So doing this derivative in here, I notice that we have this inner function, so we're going to have to do some chain rule stuff. This is going to be 1 over the stuff on the inside, but then by the chain rule, we'll have to multiply by the derivative of that stuff on the inside. So if we differentiate that x squared, that turns into 2x. If we differentiate that constant on the end, that just turns into 0, so we don't really need to attach that at all. Now I notice that we're multiplying fractions together, so I'm going to put this 2 to the x over 1. Multiplying the numerators, we get 2 to the x over. Multiplying the denominators, we get x squared plus 4. So the derivative of this function is 2x over x squared plus 4. Now this next example might be a little trickier. We're going to look at a tangent that goes through the origin. So we've got a line with slope m passing through the origin, and it's tangent to our graph of y equals the natural log of x. We want to figure out what the slope of this line is. Now, the first thing I want to look at is a graph of the natural log of x. So in general, the graph looks something like this. And then we've got this tangent going through the origin and then just barely touching our graph at this specific point on our graph. Now, we don't know what that point is, but here's what we do know. It's going to have some general x value, let's call it a, and then the y value, because our equation is the natural log of whatever x value we're plugging in, would be the natural log of whatever that a value is. Now, if we focus on this point and we want to find the slope there, well, the derivative of this natural log is 1 over x. So if we're looking specifically at that x value of a, then this would have a slope of 1 over a. But there's another way that we could find the slope of this tangent line. We know that it passes through the origin, which is the point 0, 0. So we could find the slope just between those 2 points by doing the natural log of a minus 0 over a minus 0. So that's just going to be the natural log of a over a. So what we've done is we've really found the slope of this tangent line 2 different ways. Using the derivative, we got 1 over a. Using these 2 points on the line, we got the natural log of a over a. Well, this is the same line we're talking about in here, so these 2 slopes should be equal to each other. So we can solve this equation in here to figure out what that a is supposed to be. What I'm going to do is take this a off of the bottom of this fraction and multiply it over to the other side. Well, if we have a times 1 over a, that just turns into 1. And then on the right-hand side, all we have left over is the natural log of a. We can take this natural log and actually rewrite it as an exponential function. Natural logs are base e, so we can rewrite this using a base of e. So this becomes e to the first power equals just that a value, and e to the first power is just e. So we know that that a value is just e. So now we know that the slope is going to be 1 over e. That's going to be it for this video. Thanks for watching.